Number one, the directions say, what are the variables in each graph? So let's do that first. It says, number one says the volume of pool water. And then on my left-hand side, so on my y-axis, I have volume. Then on my x-axis, I have time. So what are the two variables? Time and volume. Okay, so I've answered part of the question. Describe how the variables are related to various points in the graph. So we need to explain what's happening in this graph. So I see that this line is increasing. So my volume is increasing. So I'm going to say that my volume of pool water increases with what? Increases with what other variable? With time. Okay. Number two, I have temperature of water up here on the left-hand side. On my y-axis, I have temperature in Fahrenheit. And on my x-axis, I have depth. I see that when the temperature is higher, is up here, what is happening with the depth? So if my depth is getting bigger, what's happening with my temperature? It's going down. So as the depth of what? So you have to remember, what is it? Go back up to your label. Depth of water increases because it's getting bigger on the right, on the x-axis. If it goes to the right, it's getting bigger. As that increases, the temperature decreases. Okay. Oh, and then we forgot to answer. Our two variables are temperature and depth. Okay, number three, two variables. It's talking about plant height. So talking about the plant height and time. So plant height and time are my two variables. Now time is increasing going this way. What's happening with that plant height? It's increasing. So the plant height increases with time. Okay. Number four, match the graph with its related table. You don't actually have to explain your answers. So we see we have A, B, and C down here. So we're going to match the graph with either A, B, or C. Well, at 1, it's at 50. So I need at 1, 50. Well, it's at 60 here. At 1, it's 80. At 1, it's 50. It looks like C is going to be the right answer, but check to make sure. 2 is 100. Yep. 3 is 150. Yep. 4 is 200. Yep. So 4 is C. Okay, 5 at 1, it's 80. Well, it looks like it's going to be B. Make sure. 2 is 125. Yep. 3 is 150. Yep. 4 is 140. Yep. And 6 would have to be A, but let's make sure. At 1, it's a little bit more than 50, which would be 60. And that looks like it is good. Okay, next page. All right, it says sketch a graph to represent the situation and label. Okay, so it says you buy 2 shirts, the third one's free. So the first thing you need to do is figure out what your 2 labels are. So we're going to draw a little graph. Well, I'm talking about shirts and then talking about them being free. So that would be money. So we're going to say shirts and cost over here. Okay, and we're just going to sketch the graphs. We're not going to make it very perfect, but in this one, I do want to make some shirts so that way it's easier for you to understand. So if I don't buy any, I'm at 0. If I buy one shirt, I have to pay some kind of money, okay? And it doesn't say specifically what it is. If I buy 2 shirts, it's that exact same amount, so like better increase by the exact same amount. But then if I buy 3 shirts, my cost didn't go up, so I need to level out. And again, if I buy another shirt, I have to pay for it. If I buy another shirt, I have to pay for it. And then again, my 6th shirt would be free, so it levels out. And the reason I chose to do dots on here is because that's called a discrete graph. You can't really buy a quarter of a shirt, so there's really no reason for us to make that continuous there. Number 8, you warm up for gym class, play basketball, and then cool down. So 2 variables in here. Well, I know I have time, okay? And what could be changing with time if I'm warming up for gym class and then cooling down? Well, I would say my heart rate. Okay, some important things. You probably don't want to start here because I hope you're not dead before you start playing. So don't start at 0 because you have a heart rate even if you're not playing basketball at that time. So we're gonna warm up for gym. So we're gonna warm up. So my heart's gonna increase, but it's not gonna increase dramatically. I'm not running right away. I'm just warming up. Okay, so I'm gonna make a nice curved line. Then I play basketball for a while. So when my heart rate is finally increased, I'm gonna probably stay at that same heart rate for a while because I'm playing basketball. And then I'm gonna cool down. Now, I personally think that the cool down is gonna take a lot longer. So you're gonna try to make that longer. And remember, you don't wanna go back down to 0 because you don't wanna not have a heart rate. Okay. The temperature warms up during the day and then decreases at night. So 2 variables, I hear time and I hear temperature in that problem. Okay, temperature could start at 0. Okay, that's a possibility. Warms up during the day. So we're gonna say it's probably gradual warm up. Happens kind of fast because the sun's out. And then at middle of the day, it probably stays there for a while. Stays at that same temperature around noon till probably about 3 or 4 until the sun goes down. And then it's gonna start cooling down. So then we're gonna make this. And then when it comes nighttime, it's probably gonna stay at that nighttime temperature for a while. Okay, number 10. DVDs cost $19.99 each for the first 2 purchased. Then after that, they cost $6 each. Describe and correct the error in sketching the graph represented by the total number of DVDs purchased. So when he buys one, it's almost 20 bucks. He buys another, he has to pay another 20 bucks, so it's 40. And if he buys that third one, it's only $6. But what did he do? He went down to $6. He forgot he hadn't added to that total. So really, this should have been right about here. So that's how we're gonna fix the graph. I'm just gonna draw it on there. Okay, and then I'm gonna scribble this out. So that's us fixing it. And you're just gonna describe what happened. So he forgot to add the cost to his previous total. Okay, number 11. Sketch a graph of each situation. Are the graphs the same, yes or no? Okay, so we're gonna graph a situation for A, and we're gonna graph a situation for B. It says, your distance from school as you leave your house and walk to school. So what are my two variables? Well, I want distance from school. So I'm going to put that on the side and put distance school. Okay, and that's going to be the same here. Now, what is varying with that distance from school? It is time. A lot of graphs will have that bottom label be time. Okay. Okay, your distance from school as you leave your house. So if I'm leaving my house, I'm really far away from the school. I haven't gotten there yet, so I need to start high. Okay, and then I'm walking. And I'm walking to school, so I'm going to get closer and closer and closer to the school, probably at a pretty decent, steady walk, and then eventually I'll arrive at the school so I can stop at 0. Now, B says your distance from school as you leave school. Well, I'm already at school, so I'm starting at 0, and then I'm walking home, so I'm getting farther and farther and farther away from school. Are these graphs the same? No. And why aren't they the same? Because one you started at home and one you started at school. Okay, next page. All right, the graph shows your distance from the practice field as you go, home from practice. You received a ride from a friend back to his house where you ate supper, then you walked from there. Which point represents the time when you are walking home? Okay, so we have time, we have distance, and we're going to read through it again. You received a ride from a friend back to his house. Okay, so your distance is going to increase. Where you ate supper, so your distance doesn't change there for a while. So right here is when we're eating supper. Right here is when we're receiving our ride. Then you walked home from there. Which point represents a time when you're walking home? Well, is it C or is it D? So remember, my distance is going to be increasing because I'm moving. It didn't say distance from home, it just said distance in general. So that's like your step counters, okay? It doesn't go back down. It just keeps increasing. And so most of you already know that the answer is D. Okay, number 2. Which table is related to the graph at the right? So you have to compare. So I have time and I have temperature. So the first thing is time and temperature. So I need time and temp, time and temp. Oh, I have temp and time. Is that what I have? Nope, because it's always X comma Y. So we're going to get rid of that because our X is time. And so we're going to get rid of I. So we're already down to 50%. So now we just have to make sure when time is over this much, temp is up this much. Well, is time 68 here with temperature being 1? Does that make logical sense? And is this only going up 1 to 2 to 3 to 4? This looks more like more than a jump than an equal amount. So this doesn't make sense. So after 1 hour, temperature 68 degrees. That makes sense. After 2 hours, it's 73. At 3, it's 78. And then 4, it jumped a little bit to 85. Okay, number 3. How are the variables related on the graph? Okay, so we have speed and height. So we're better talk about speed and we better talk about height. So remember, if speed is going this direction, right? Speed would be increasing. So as speed increases, so I can get rid of these two. Okay, what's happening with height? Well, height is going up. So it is increasing. So as speed increases, height increases. Okay, number 4, we have to make a graph. Okay, it says for the race, you swim 1 mile, run 10 miles, and bike 25 miles. Sketch a graph to represent the relationship. Okay, so we have to figure out what our 2 labels are. Well, we know that we have time, and we're doing a race, so we have distance over here. Okay, I swim 1 mile. Well, that's going to take some time. Swimming doesn't go as fast as running or biking would. So you're going to start at 0 because you're going to start at the starting line. Okay, and I'm going to swim for a while, and I'm not the fastest swimmer in the world, so my pace is going to be pretty slow. Mine would not be even slower than that, but okay, and then I'm going to stop there for a while. Now that was my 1 mile. Now I'm going to run 10 miles. Well, most people can do that a lot faster, and my distance is going to increase a lot faster because I can run faster. So I'm going to make that much faster, and that's 10. To like 10 miles. And then I'm going to hop on my bike and go 25. That's even going to be faster than that. So I'm going to hop on that bike and really cruise it up to 25. Okay. Okay, next page. Number 7. It says which scatter plot, so these are scatter plots because they have just a bunch of dots, shows a negative correlation. So which one shows a negative slope? Which one's going downhill, strictly downhill? Well, this one looks like if you drew a line of best fit in there, it would be going uphill. This one looks like it could be going downhill. This one, I don't feel like I can draw any line because it doesn't look like anything's consistent. Unless you drew like a line this way. And then this one's going down and then it's going back up. So I can't use that one. Can't use that one. It's not positive, so it must be B. Okay. It says, what does the answer to question 7 tell us? So it's asking with these two labels, price and purchased. So as price what? If I'm going this direction, it's doing what? It's increasing. So as price increases, so you probably can get rid of D. And then there's no relationship. That would be something like C. Okay. As price increases, the number purchased what? Decreased, not increased. So we can answer C. Okay. Number 9. Which of the following relationship is one likely of causation? So causation is one cause the other to happen. It's causing the other one to happen. As the water temperature of a pond increases, the number of fish in the pond decrease. Could the water temperature potentially decrease the amount of fish? It's possible. Let's read the other options. As the number of visits to a new website increases, the number of people evacuating a city increases. Do you think an evacuation of a city and a website view are going to cause each other to happen? No. As credit card usage increases, the unemployment rate increases. So just because I use my credit card, does that mean that I'm going to cause unemployment? No. Okay. As the number of people snowboarding increases, the number of snowmen built increases. Is that for sure, just because someone went snowboarding, is it going to for sure cause more snowmen to be built? No. Now, could there be like a little bit of a correlation there? Yes, because I mean, there could be snow and then that sort of thing. But just because there is someone snowboarding, does that mean that snowmen are going to be built? No. Now, if the temperature of the water increased, would that definitely cause some fish to die? Yeah, that would. So this one is of causation.